Hi, welcome to the video, guys. My name is Pushpinder Gill, and today we're going to do data sufficiency in remainder problems, right? So today we're going to do data sufficiency when it comes to remainder problems. So this is for the audience who wants to give the GMAT test and people who are, preparing for the CAT test as well. So before we start with the video, guys, this is our web address, that is perfect-scores.com. Make sure you explore that, and don't forget to like us on the Facebook page, which is facebook.com/perfectscores. And don't forget to send me your valuable feedback at perfectscores89@gmail.com. Right? So let's go ahead and get started, guys. So today it's about data sufficiency. So I hope you watched the remainders first part. You watched the first video in which we did a couple of concepts when it comes to remainders. So let me just revise those concepts, in a quick way. Let's suppose if I divide 49 by 4, right? So I'll have 12 here, I'll have 48 here, and I'll have 1 as the remainder. So in this case, I can say that 49 is equal to 12 into 4 plus 1, right? Similarly, if I divide P by Q and I have, let's say, A here, and something comes here and I have remainder R, then I can say that uh, the value Q is equal to P into A plus R. So this is the basic on which the whole remainder theorem is dependent on, right? And the next thing that we did was, this was the first thing. The next thing we did was, whatever operation you do on numbers, let's suppose if x1 is divided by y and x2 is divided by y, over here the remainder is r1 and over here the remainder is r2. Similarly, if x1 plus x2 is divided by y, the remainder is going to be equal to r1 plus r2. Similarly, if x1 minus x2 is divided by y, the remainder is going to be r1 minus r2. And if x1 into x2 is divided by y, the remainder is going to be r1 into r2, right? So this is something we did in the first video. And the last thing was that remainder always follow patterns, right? So this was there, that remainder always follow patterns. The remainder when, we did a lot of couple of patterns. So for you to do that in detail, kindly watch the first part of the remainder video, right? So these are the three things that we did, and based on this only, I'm going to show you how to tackle some data sufficiency questions, how to tackle data sufficiency when it comes to remainder problems. So in case you haven't watched the data sufficiency video, kindly go ahead and watch that as well, because that will also help you in understanding the premise of data sufficiency questions. So let's go ahead and get started, guys. All right, so I'm gonna follow a different approach here, the same approach, same approach. I'm gonna solve questions and show you how to apply the remainder theorem when it comes there. So these are some commonly searched questions when it comes to GMAT, right? So these are some commonly searched questions over the internet. So I'm gonna solve all those questions here. So it says that if R is the remainder when positive integer n is divided by 7, right? So the question says that when n is divided by 7, the remainder is r, right? So the question is asking the value of r. So this is what the question is asking. Let's see what statement 1 tells us. It says that when n is divided by 21, the remainder is an odd number. So the remainder is an odd number, right? So what we can do over here is we can go by our plug-in method. Let's suppose that the value of n is equal to 23. So when the value of n is equal to 23 and you divide 23 by 21, the remainder is, let's say it's equal to 24, right? When you divide 24 by 21, the remainder is plus 3, which is actually an odd number, right? And if I say the value of n is equal to 26 and you divide 26 by 21, the remainder is equal to 5. So I'm getting two different values of remainders. That means statement 1 is eliminated, right? So if statement 1 is eliminated, I'm down to answer option B, C, or E. Now, the question over here says that when n is divided by 28, the remainder is 3. Pretty easy one, right? So when n is divided by 28, the remainder is 3. So if n is divided by 28, the remainder is coming out to be 3. So let's pick up some numbers. Now it's very, very important that you pick up some numbers and check out if there is a pattern coming out. Okay. So let's pick up at the first number, which is divisible by 28. It gives us remainder 3. That would be 31. And the next number is going to be, so if you divide 28 by 31 by 28, the remainder is going to be plus 3. The next number is going to be 31 plus 28. The next number is going to be 31 plus 28 plus 28. So these how the numbers are going to be. So no matter what number I divide by 7, over here the remainder is plus 3. Over here the remainder is going to be plus 3 from here. But from here the remainder is going to be 0. And eventually the remainder is going to be 0 from all the possible numbers. And I will always get plus 3 remainder when I divide any number which gives 3 remainder when divided by 28. Hence, statement B gives me an accurate answer. It gives me a unique answer that then you divide a number by 28, the remainder is going to be 3. Hence, answer option B is my answer. C and E are eliminated. Pretty straightforward question, guys. It says that when n is divided by 28, the remainder is 3. So, we don't need to think too much in a question. I don't want you to become a math guy. I want you to become a logical guy. Just pick up a number, 31. The next number would be 31 plus 28. The next number would be 31 plus 28 plus 28. And that's how the things is going to flow. And whenever you divide all these numbers by 7, the remainder is always going to be plus 3, right? So that means my answer is option B. So suppose you've understood that, guys. Moving forward to the next question. Now the next question over here says that if n and m are positive integers, so n and m are positive integers, what is the remainder when 3 to the power 4n plus m plus 2 is divided by 10? Now there are two things that you should know in this question. Whenever the question is about exponents and remainders, it is always about patterns, right? So understand that. Whenever the question is about exponents, it is always about patterns. And whenever the question is asking you the remainder when something is divided by 10, right? So remainder by dividing a number by 10, it is always asking you the units digit of the number, isn't it? So if you divide 23 by 10, the remainder is 3. If you divide 14456 by 10, the remainder is 6. So if you divide anything by 10, the remainder is equal to the last digit of the number, right? So suppose you're understanding that. Let's see whether we can find a pattern here. First statement over here says that n is equal to 2, right? So this is what the first statement says. So this is going to be 3 to the power 4 into m, which is 4 into 2 plus 2 plus m divided by 10. This is going to be 3 raised to the power m plus, so 4 into 2 is going to be 8, 8 plus 2 is going to be 10. Now let's go ahead and plug in, guys. Let's suppose m, now we have to find the cyclicity of 3, because it will always be patterns. The remainder are always going to be in patterns. So what is the units digit of 3 to the power 1? That is going to be 3. What is the units digit of 3 to the power 2? That is going to be 9. What is the units digit of 3 to the power 3? But 9 3s are 27. That means it's going to be 7. What is the units digit of 3 to the power 4? That is going to be 81, which is 1. Similarly, 3 to the power 5 will have 3 as units digit. 3 to the power 6 will have 9 as units digit. 3 to the power 7 will have 7 as unit digit. And 3 to the power 8 I will have 4 as unit digit. Now let's do one thing. Let's go ahead and plug in. Let me say that the value of m is equal to 1. If the value of m is equal to 1, then this expression over here becomes 3 to the power 11. Now what is the remainder that 3 to the power 11 is going to give me when I divide 3 to the power 11 by 10? Well, 1 comes here, 2 comes here, 3 comes here, 4 comes here. 5 is going to come here, 6 is going to come here, 7 is going to come here, 8 is going to come here, 9, 10 and 11. That means the remainder when I divide 3 to the power 11 by 10 is going to be equal to 7. Repeating once again, guys. I want to know what is the remainder when 3 to the power 11 is divided by 7. That is going to be, see, all the powers of 4 are going to come here. 4, 3 to the power 8, 3 to the power 12, 3 to the power 16. Everything is going to come here. So if 3 to the power 12 is going to come here, that means 3 to the power 11 is going to come here. That means it is going to have 7 at the end. Similarly, 3 to the power 12, when it is divided, if I plug in m equal to 2, right? So I'm going to have, if I plug in m equal to 2, then I'm going to have 3 to the power 12 divided by 7. And then the remainder is going to be equal to 1. So since I'm going to have different values of remainders, that means first statement is insufficient. I'm down to answer options B, C, or E. Now let's go ahead and plug in the second answer option, which says m is equal to 1. So if m is equal to 1, then this expression over here is going to become 3 to the power 4n plus 3, right? So that is going to become 3 to the power 4n plus 3. Now the same cyclicity of 3 is going to follow. I'm just going to write down that cyclicity. Same pattern is going to follow for the remainders of 3. Is going to repeat after every fourth term. Now if I plug in n equal to 1, then this becomes 3 to the power 7, 4 plus 3. If I plug in n equal to 2, then this becomes 4 into 2, 8. 8 plus 3 is 11, 3 to the power 11. So you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When I plugged in n equal to 1, the value came 7. There was 7 at the end. When I plugged in n equal to 2, the value came 11. There was again 7 at the end. When I'll plug in n equal to 3, this will come 4 into 3, 12, 3 plus 3, 15, 3 to the power 15, which will again come here, and there will be 7 at the end, right? So if you observe this, this is nothing but will always give me a 3 remainder when I divide this by 4. Hence, every time my value is going to come here, I'm going to end up right here when I use the cyclicity. Hence, this is giving me a unique answer, which means statements 2 is sufficient. Hence, my answer is option B. So I'm going to repeat once again what I did here. 3 to the power 4n plus 3. See, no matter what value n takes, this is always going to be 3. This is always going to be 3 more than 4. 3 more than a multiple of 4. That means every time my clock is going to stop here when I calculate the remainder. Every time I will be having 7 at the end, which means 7 is what will remain at the end, and 7 will always be the remainder when I'll divide this expression by 7 if the value of m is equal to 1. That means statement 2 is sufficient, and my answer is option B. Fine, guys. Let me have some water. Alright, guys. Let's go ahead and start this question here. Now this question over here says that if p is a positive odd integer, what is the remainder when p is divided by 4? Now over here p is an odd integer and a positive. The question is asking what is the remainder when p is divided by 4. So the question is asking the remainder when it's divided by 4. Now the question over here says that when p is divided by 8, the remainder is 5. I hope you would understood from the very first question, p divided by 4 will also give you the same remainder. In case you want to double check it, plug in some numbers. Let's suppose the value of p is 13. 13 divided by 8 will give you what remainder? 13 divided by 8 will give you 5 remainder. And I'm sorry, 13 divided by 8. Let's check that. 13 divided by 8 is going to give you 5 remainder, and 13 divided by 4 is going to give you plus 1 remainder, right? Let's see another number. Another number is going to be 13 plus 8, isn't it? That would be equal to 21, right? 21 divided by 8 will give you 5 remainder, but 21 divided by 4 will give you plus 1 remainder. So basically, if I use algebra here, it says that when p is divided by 8, the remainder is 5. So when p is divided by 8, the remainder is 5. That means p is equal to 8 into some integer plus 5. And if I divide p by 4 and if this gets divided by 4, from here I will get a 0 remainder, and from here always I will get a plus 1 remainder, which means statement 1 is sufficient. Hence is either answer option A or answer option D. Let's pick up the second statement. The second statement says that p is the sum of squares of two positive integers. So it says that p is the sum of squares of two positive integers, any two positive integers. Let's go ahead and plug in. Let's suppose a is equal to 1 and b is equal to 3. Let's plug in that way. So if a is equal to 1, b is equal to 3, then sum of these two squares is going to be 1 plus 9, which is 10. When 10 is divided by 4, the remainder is plus 2. Let's pick up some other number. Let's say a is equal to 7 and b is equal to 4. This is going to be 49 plus 16, which is going to come down to be equal to, so if I add these numbers 49 and 16, that is going to come down to 65. 49 and 16, if I add this, it's going to come down to 65. And what is the remainder when this is divided by 4? Over here the remainder is equal to plus 1, right? So p is a positive odd integer. Now it says that p is a positive odd integer. This is not even going to qualify, right? It says p is a positive odd integer, so p cannot be equal to 10, right? So I cannot use that. So over here the remainder is plus 1. Let's check another number, right? For p to be a positive odd integer, one number will have to be even, another number will have to be odd. Let's plug in some other number. Let's say p is equal to 3 and q is equal to 4. And if I add any number here, 9 plus 16, that is going to be equal to 25. And from here, if I divide it by 4, the remainder is still going to be equal to plus 1. So from here, something should tinkle in your mind and you should say, why every time the remainder is coming out to be plus 1? So either you'll plug in several times and in the end we'll say this statement is sufficient, or you can use a little bit of algebra as well, right? So sorry. So one of them is an odd number and one of them is an even number. So one of them is an odd number and one of them is an even number. That means PA is gonna be square of an even number and the square of an odd number, right? So I can write it like this or like this, doesn't matter. So over here, an odd number can be written as 2b plus 1, an even number can be written as 2a. So p is gonna be 4a square plus 4b square plus 4 of 4b plus 1, right? So if I expand it, it's a square plus b square plus 2ab, a square plus b square plus 2ab. So if you divide this by 4, the remainder is gonna come plus 1 always, and these are gonna cancel out. That means no matter what number you plug in, every time you're gonna get plus 1 remainder, which means this is also sufficient. Hence my answer is option D. So fine, I suppose you're understanding over here. Each and every word is important to the question. As you see that p is a positive odd integer, that made a difference to statement 2. So if he says p is a positive odd integer, kindly take hint from there, and that's the way to go into the question. This is a question is trying to give you a hint here, right? So to use that. Rest, always attack the question with plugging in. That will help you to understand what could be the answer and then conclude it with algebra, right? So this is what we did here. We concluded it with algebra and hardly is going to take 2 minutes for you. Okay, so suppose you've understood that, guys. Moving forward. All right, so let's go ahead and do this question. Now this question says that p and n are positive integers and p is greater than n. What is the remainder when p square minus n square is divisible by 15? So statement 1 over here says that the remainder when p plus n is divided by 5 is equal to 1. So 1 is the remainder. when p plus n is divided by 5. Let's suppose p plus n is equal to 6, right? So if p plus n is equal to 6, then in this case, let's say p is equal to 3 and n is equal to 3, right? Or let's take a simpler scenario. Let's say p is equal to 4 and n is equal to 2. So if p is equal to 4 and n is equal to 2, then p square minus n square is going to be equal to 16 minus 4, which is equal to 12. And when you divide 12 by 15, the remainder is equal to plus 12. Let's go ahead with another number. Let's say p plus n is equal to 6 only. But in this case, let's say p is equal to 5 and n is equal to 1. If p is equal to 5 and n is equal to 1, then p square minus n square, is going to be equal to 25 minus 1, which is equal to 24. And if I divide 24 by 12 by 15, the remainder is going to be equal to plus 9. So since I'm getting two different remainders, that means statement 1 is insufficient. I'm down to answer option B, C, or E. Let's go with the second statement. The second statement says that the remainder when p minus n is divided by 3 is equal to 1. Let's suppose p minus n is equal to 4, right? When you divide 4 by 3, the remainder is 1. If p over here is equal to 5 and n over here is equal to 1, the values 5 and 1 are actually satisfying this. You can clearly see that. Then the remainder when p square minus n square is divided by 15 is equal to plus 9. As you can already see there, it's equal to plus 9. Now all we need is a different scenario, right? Let's suppose p over here is equal to 6 and n over here is equal to 2. Then p square minus n square is going to be equal to 36 minus 4, which is equal to 32. And when you divide 32 by 15, the remainder is plus 2. That means this is again giving me two different answers. Hence, this is sufficient. That means answer option B is gone. Now, usually when we combine both these statements, algebra is something that we should be using. Now over here, as you can see that it says that when p plus n is divided by 5, the remainder is plus 1. And when p minus n is divided by 3, the remainder is plus 1, right? So when p plus n is divided by 5, the remainder is plus 1. And when p minus n is divided by 3, the remainder is plus 1. So from here I can say that p plus n is equal to 5 into an integer plus 1, and p minus n is equal to 5 into an integer plus 1. So if I multiply these both numbers, from here I will get p plus n into p minus n is actually equal to 5 into x plus 1 into 5 into y plus 1. That means p square minus n square is equal to 25xy plus 5x plus 5y plus 1. Now I have to tell what will be the remainder when this over here is divided by 15, right? So this is what I have to tell when this is divided by 15. Well, when x is equal to 1 and y is equal to 1, then this expression comes down to be equal to 25 plus 5 plus 5, which is going to be 35 plus 1, which is going to be 36. If I divide 36 by 15, the remainder is plus 6. Let's say x is equal to 2 and y is equal to 1. When that is the case, then this over here is going to be 50 plus 10 plus 5 plus 1. Then it's going to be 60 plus 1. That is going to be, this is going to be 60 plus 6. That is going to be 66. And when I divide 66 by 15, the remainder is again plus 6. Let's check another value. Let me say, so I'm going to use some values here. I'm going to say x is equal to 2 and y is equal to 2. If x is equal to 2 and y is equal to 2, Then this over here is gonna turn down to 25 into 4, which is gonna be 100. 5 into 2, which is gonna be equal to 10. 5 into 2 is gonna be 10, and this over here is gonna be 1. So this is gonna turn out to be 121. If I divide 121 by 15, the remainder is plus 1. So I'm getting different answers here. I'm getting plus 6, I'm getting plus 1, which means even combining is insufficient. Hence, my answer is option E. So suppose you're understanding me here, guys, what I'm trying to do. I'm using some basic math here, nothing more. And I'm actually trying to disprove and showing you how each answer option is disproving. I'm not relying on some assumptions which, I cannot use at all. Just say, okay, you know what, I don't know the value of P, I don't know the value of N, I won't be able to get you the answer. That is not we're going to use here. I gave you a proof of how each answer option was, how each statement was not sufficient. You had that proof. So suppose you've understood this one, guys. Moving forward. Now let's go ahead and do this question, guys. This question says that what is the remainder when positive integer x is divided by 3? So the question is asking what is the remainder when x is divided by 3. Let's check the first statement. It says that when x is divided by 6, the remainder is 2. That means x is equal to 6 into something plus 2. So if I divide this by 3, from here it's gonna be a 0 remainder, but from here every time I'll get a plus 2 remainder, which means I have a unique value as my answer. That means first statement is sufficient. It's either answer option A or answer option D. Let's see the second statement. It says that when x is divided by 15, the remainder is plus 2. So that means this x is equal to 15 into something plus 2. Again, if I divide this whole by 3, from here I'm going to have a 0 remainder, and from here I'm going to have a plus 2 remainder. Again, a definite answer. That means answer option A is gone and D is my answer. And you can always double check. When D is the answer, both the answer options should give you the same value. I'm sorry, which is given by each answer option here, right? So suppose you're understanding this, guys. Let's move forward. Okay, so that's so easy, right? So now I suppose things must be becoming a lot easier for you. So this question over here says that x, y, and z are positive integers, right? So it says that x, y, and z are positive integers. What is the remainder when 100x plus 10y plus z is divided by 7? Now you can see that this becomes a 3-digit integer, isn't it? Right? So it actually becomes a 3-digit integer. So 100x plus 10y plus z is actually divided by 7. So let's check out what do we get here. The first statement says that the value of y is equal to 6. That means it turns out to be 100x plus z plus 60 is divided by 7. Now if I say x is equal to 1 and z is equal to 1, this number is going to turn out to be 100 plus 61. So that means it comes down to be 161. If I divide 161 by 7, 7 times 2 is 14. 7 times 2 and 1 is 3 are 21. The remainder is exactly 0. Let me just change it a bit. If I say that x is equal to 1 and z is equal to 2, then the number would be 162, isn't it? Then the remainder is going to be plus 1 because 161 is divisible by 7. So I'm going to have different answers here, which means first statement is insufficient. It's either answer option B or answer option C or answer option E. Okay. Now, let's see the second statement. The second statement over here says that the value of z is equal to 3. That means it's going to become 100x plus 10y plus 3 is divided by 7. Let's check that out. What do we get from here? So if let's suppose x is equal to 1 and y is equal to 1, then I'm going to have this to be as 100 plus 10 plus 3. which is 113. If I divide 113 by 7, I would get the remainder to be equal to 1, right? Let's check another set of values. Let's suppose x is equal to 1 and y is equal to 2, right? So if x is equal to 1 and y is equal to 2, then it's going to be 100 plus 23. That is going to be 123, right? So if I divide this by 7, 7 times 1 is 7. Then I'll have 5 and 3, 53. So if I say 7 times 7 is 49, so from here I'll get a different remainder, which means second statement is also insufficient, which means answer option B is gone. Now I have to combine both the statements. I have to say that y is equal to 6 and z is equal to 3. So let's put 100x plus 60 plus 3. So that is gonna be 100x plus 63, isn't it? So I'll just pick up two numbers, x is equal to 1, then it becomes 163. We already know that the remainder from 163 is gonna be plus 2 because we know that it's divisible by 161. And if I plug in x is equal to 2, then it's going to become 263. And that this 100% is going to give me a different remainder. Even if you want to double check it, you can do that. 7 times 3 is 21 and 53. And 7 times 7 is 49. So from here, I will get a plus 4 remainder. Different remainders, even by combining, that means C is gone. Hence, E is my answer. So if you want to double check it, if you want to do it in a quicker way, if you want to do it in algebra way, trying to take more risk, is this is a 3-digit number. You actually need all the 3 possibilities for you to get to the answer. These are only giving you 2 possibilities, hence both the statements are insufficient, right? But it's actually a lot better to be safer than be quicker and a riskier approach, right? That this would be a very, very risky approach, because what if the question is framed in such a way that it's a trap, right? You never know. So you make sure that you get through the answer in a structured and an organized way. Okay, guys. So suppose you've understood that. Let's move forward. Now this question over here says that n is a positive integer, right? And the question is saying that r is the remainder when 4 plus 7n is divided by 3. So the question is asking the value of r. So basically, the question is asking the value of r. So from here, I would know that the remainder is plus 1. From here, I would know that the remainder is going to be plus 1. And it's going to depend the remainder when the value of n is actually divided by 3. First statement says that when n plus 1 is divided by is divisible by 3. So if n plus 1 is divisible by 3, that means if I divide n by 3, the remainder is going to be equal to plus 2. Because 1, 2, 3, 4, 5, 6, 7, 8, 9. If I draw this number line, these numbers would compound to n plus 1. That means n will always be a number which is 1 shorter than being divisible by 3. Hence, it will always give me plus 2 remainder when I divide it by 3. Right? That means I would know that what is the remainder that would be given by n when it's divisible, when it's divided by 3. That is going to be plus 2. That means from here the remainder is plus 2. From overall, the remainder is going to be plus 1 plus 1 into plus 2, that is going to be plus 2, that is plus 3. Plus 3 would amount to 0 remainder, because if you divide plus 3 by 3, the remainder is 0. The basic thing is that I would know what the remainder is. That means the statement is sufficient. It's either answer option A or answer option B. Second statement is kind of a superfluous statement. It says n is greater than 20. If n is 21, it actually gives 0 remainder. If n is 22, it actually gives 1 remainder. So I'll have multiple answers since this is insufficient. That means my answer is option A. Right? So suppose you've understood this one, guys. Thank you very much. Let's go ahead and move to the next question. Suppose you understood this one. Okay. So let's go ahead and do this question, the last question of this video. It says that if n is a positive integer and r is the remainder, so n over here is a positive integer and r is the remainder when n minus 1 and n plus 1 is divided by 24. So when you divide n plus 1 and n minus 1, the remainder is r. First statement says that n is not divisible by 22. So let's say that n over here is actually equal to 3. If n is equal to 3, then 3 minus 1 and 3 plus 1, it's going to be equal to 2 into 4, which is going to be equal to 8. And if I divide 24 by 8, the remainder is equal to plus 8. Let's check the next number. Let's suppose n is equal to 5. Then 5 minus 1 and 5 plus 1 is going to be equal to 4 into 6, which is going to be 24. If I divide 24 by 24, the remainder is going to be 0. That means this statement is giving me two different answers, which means it's insufficient. That means it's either answer option B, answer option C, or answer option E. Let's pick up the second statement. It says that n is not divisible by 3. That means this number over here is not divisible by 3 and equal to 5. Sorry. So if I plug in n equal to 5, the remainder is going to be 0. Let's plug in the next number. Let's say n is equal to 7. Then 7 minus 1 into 7 plus 1, that is going to be equal to 6 into 8. If I divide 6 into 8 by 24, the remainder is still 0. Let's plug in the next number if we have to find a pattern. Let's suppose n is equal to 9. Sorry, it says that n is not divisible by 3. Let's plug in an even number here. Sorry. Let's suppose n is equal to 8. Then it's going to be 8 minus 1 into 8 plus 1. Then it's going to be 9 into 7, which is equal to 63. If I divide this by 24, I definitely know that the remainder is not equal to 0. So I'm getting remainder equal to 0 and remainder not equal to 0, which means this statement is also insufficient. Hence, answer option B is eliminated. Now let's go ahead and combine both the statement, guys. It says that n is not divisible by 2 and n is not divisible by 3. So no matter what number I plug in here, 1, 2, 3, 4, 5, 6, 7, 8, 9. I cannot plug in 2, I cannot plug in 3, I cannot plug in 4, I cannot plug in 6 because it's not divisible by 3 and not divisible by 2, 8 and 9. Let's move even more forward just to see whether we can get a pattern or not. I cannot plug in this, cannot plug in this, cannot plug in this. Now if I plug in 1, 1 minus 1 and 1 plus 1 is 0. If I plug in 5, 5 minus 1 and 5 plus 1, it's 24. 24 divided by 24, remainder is 0. If I plug in 7, already I know that the remainder is 0. If I plug in 11, it's going to be 11 minus 1 into 11 plus 1, which is going to be 120. The remainder is still going to be 0. If I plug in 13, the remainder is still going to be 0. So every time I'll get remainder 0 when I divide this by 24. If you want to waste time and use algebra, well, we can do that, but there's no point here. You can always see a pattern emerging. That means by combining it's sufficient. Hence my answer is option C. Right? So suppose you're able to understand what I'm trying to do here, what I've done here. Simple basic plugging in, simple elimination. And in the end, when I combined, I just found a pattern. Right? So the answer over here is going to be option C. Right? So we solved an ample amount of questions, guys. Thank you very much for watching this video. So this was the second video on the remainders, which actually talked about data sufficiency questions. What to do next? Well, I'll be throwing a lot of videos in next week only, right? So I'll be putting up more videos online. So just make sure that you explore more about us on perfect-scores.com. Don't forget to throw us a like at facebook.com/perfectscores and give me your valuable feedback at perfectscores89@gmail.com. So this will be the video, guys. Thank you very much. Keep watching and I'll see you in the next one.